Hello, this is Slamel here, and you might have heard by someone that the biggest number with a name is called a Googleplex. Now, if you don't know what this is, I'm going to basically explain it to you. Basically, it's 10 followed by a Google zeros. And a Google is 10 followed by 100 zeros. So if a Google is 10 to the power of 100, then Googleplex is 10 to the power of 10 to the power of 100. Now, I don't like writing power this way because, firstly, all the numbers at the top are very, very small and they're quite hard to see. Secondly, it goes in a weird direction I don't really want to go in. So there's this new way of writing it, which is basically where you write 10 up arrow, which means to the power of 10 up arrow 100. So now that's out of the way, let's get into explaining the number way bigger than Googleplex, Graham's number, and why that number will literally make your brain explode. So first I need to tell you what, well, you don't know what it is. I mean, you do know what it is. Addition. Now, what is addition? Well, addition is basically where you add two numbers together. So the two numbers I'm going to be using are A and B. So you already know what addition is. It's basically where you add together A and B. So multiplication is where you do A multiplied by B, which is A, add A, add A, add A, B times. Now there's powers, which is basically A to the power of B, using this arrow notation because it's clearly better than regular notation, is same as A times A times A, B times. Now, what if you wanted to write A to the power of A, 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 and keep going, B times. Now, luckily, we have a solution to that problem, which is A double arrow B, which is basically A to the A to the A to the A, B times. Now, we also have A triple arrow B, which is A double arrow, A double arrow, A double arrow, A double arrow, and keep going on, B times. Now, a quadruple arrow B is A triple arrow, A triple arrow, A triple arrow, B times. So, for example, 2 double arrow 5 can be written as 2 arrow 2 arrow 2 arrow 2 arrow 2. Now, 7 triple arrow 3 can be written as 7 double arrow 7 double arrow 7. Now, we're going to look at a number called 3 quadruple arrow 3. Now, I'm going to basically explain to you how massive this number is. So, let's start with writing out. So, 3 quadruple arrow 3 is basically 3 triple arrow. Now, it's going to be 3 times. It means we're going to have 3 occurrences of the number 3. So, these are the 3 occurrences of the number 3. So, we have 3 triple arrow, 3 triple arrow 3. Now, to make it simple, I'm going to just write brackets over the 3 triple arrow 3 because that's how it works. So, now we need to work out 3 triple arrow 3. So 3 triple arrow 3 equals 3 double arrow 3 double arrow 3. And 3 double arrow 3 equals 3 single arrow 3 single arrow 3, which is 3 to the power of 3 cubed, which is 3 to the power of 27, which is, I'm not going to write the number before, but it's about 7.6 trillion. I might be remembering that number wrong, but it's definitely around that big. So, now let's go back to 3 to the triple arrow 3 equals 3 double arrow 7.6 trillion. Because 7.6 trillion is 3 double arrow 3. So 3 double arrow 3 double arrow 3 is 3 double arrow 7.6 trillion. Now, which means 3 to the power of 3 to the power of 3 to the power of 3. I'll go and write it normally here, because that's how it's normally written. Keep going. 7.6 trillion times. That's so many times. Now, to put that into perspective, 3 is 3. 3 to the power of 3 is 27. Add another 3, you get 7.6 trillion. Add another 3, and it's already bigger than a Googleplex, which is that number we saw earlier. Now, Googleplex seems very big on the surface, but you can just stack together a few 3s, and it's already bigger. Now, that's only with 4 of them, but if you keep adding more until you have 7.6 trillion of them, that's going to be a massive, massive number. Now, if we wanted to have 4 arrows 3, remember that's 3 triple arrow, a massive number. Going to write no for short, so basically it's a massive no. Now, 3 triple arrow, a massive no, is basically 3 double arrow, 3 double arrow, 3 double arrow, keep going on, a massive no times. Now, I can't even explain that because a massive no is incredibly big. I mean, even to write it out, you need to go all the way to the sun. So, a massive no is such a big number that I can't even explain it. So if you're doing 3 double arrow itself, a massive no times, double arrow is even extremely exponential. See how quickly this normal power level, single arrow goes really quickly, double arrow goes really fast as well. So 3 quadruple arrow, 3 is called, I'll just call it so big, because it's so big it makes a massive no look small. So to put that in perspective again, 3 single arrow 3 is 27, which is quite short. 3 double arrow 3 is 7.6 trillion. 3 triple arrow 3 is way bigger, it gets to so big. And 3 triple arrow 3 is a massive no. And 3 quadruple arrow 3 is so big. So big it makes a massive no seem tiny. So if we did 3 to the 5 arrows of 3, it would be incredibly big. Now, I'm going to flip back on the other side just so I have more room. But basically, 3 to the quadruple arrow of 3 has another name, which is G1. Now, this is a part of the G sequence. So, G2... how many arrows would G2 have? If it had 5 arrows, G2 would be so big, it would be the biggest number ever. Now, we've already seen how adding another arrow can make a huge, huge difference. Adding one more arrow can make the previous number look tiny. So, how many arrows does G2 have? It will have G1 arrows. Now, G1 is so big, it's impossible to explain. And it will have that many arrows, which means we'll replace a massive number with a number that makes that massive number look like basically 0.1. That it's to say it's exponential is an understatement. So if we're adding that many arrows, it will make the number really, really big. So G3 will have G2 arrows, G4 will have G3 arrows, and G64 will have G63 arrows. Now, it's this G64 number, which is Graham's number. So, that is why Graham's number, and a fun fact about Graham's number is, if you tried to memorize all of its digits when written out as a normal number, your brain would literally explode. Now, the last digit of Graham's number is 7, And we've now passed the 10-minute mark, so I'd like to say thank you for watching this video. Please subscribe. We're going to have a few more fact videos coming out after this one. But for now, thank you for watching, and I'll see you all later. Goodbye, everyone.